Hey, hi, welcome back to the channel. If you're watching this, you're already taking your next step in Python. And trust me, this one's a game changer. Today, we're going deep into something that confused me as a beginner. But once I got it, it made me fall in love with programming. And that's object-oriented programming, or just OOP. If that term sounds big or scary, relax. You don't need to be a genius to get it. I am going to explain everything in the simplest way with stories, analogies, and live coding examples. Imagine we are sitting down for a coffee and I'm showing you what I wish someone had showed me. What is OOPS really? OOPS is a way to organize your code, but not like folders on your desktop. Think of it like building blocks. You're creating mini machines that each have their own job and they talk to each other. Let's say you're building a game. You'll have a player, a scoreboard, maybe enemies. Each one is an object. Each object has properties like health, scores, and behavior like jump, attack. That's OOP in action. Now, why does this matter? Because without OOP, your code becomes a spaghetti mess. I know, I've written that kind of code. You change one thing, five other things break. Pro tip, OOPS is not just about writing code. It's about thinking like a builder, modular, clean, and reusable. Let's say you run a bakery. You have cakes, breads, and pastries. Each one is a type of product with its own ingredients, baking time, and price. In code, you'd have a product class, and cake, bread, and pastry could be different objects of that class. Each object knows what it is and what it does. It's just like real life. That's why OOP clicks so hard because it mirrors the way we already see the world. Enough talking. Let's get our hands dirty with some actual Python. Let's say we declare a class developer, then we have definition in it that takes three arguments: self, name, and language. Then we just say self.name equals name and self.language equals language. It also has one more definition, which is definition code. It takes argument self and then it prints self.name is coding in self.language. Let's break this down. Class developer. We are creating a template. Method init. This is like the birth moment for an object. Self.name equals name. Here we are saying this object will remember the name it was given. Definition code. This is the behavior, the action, what this object can do. Beginner insight. Every time you create a class, think, what is this thing? What does it know? What can it do? That's the formula. Let's create two objects with the same class. Let's say dev1 is equal to developer, and then we pass in two parameters, Anna and Python. And then second object with the same class developer, it takes another argument, Jake and JavaScript. Now, when we call dev1.code, it should print Anna is coding in Python. And when I call dev2.code, it should print Jake is coding in JavaScript. Let's try it out if it gives the exact expected result. Just like that, We created two separate developers, same class, different objects, each with their own memory. I remember the first time I wrote code like this. It felt like magic, like I was creating something alive. Now let's talk about the core concepts that make OOPS powerful. These are called the four pillars of OOPS, and you'll see them everywhere in real projects. First, what is encapsulation? Imagine a washing machine. You push buttons, it works. You don't need to know how the motor runs inside. It's hidden. That's encapsulation. Have a look at this code, wherein we have a class bank account which has three different definitions: init, deposit, and get balance. If you see self dot underscore underscore balance equal to 0, here we are declaring a private variable, which means this should be accessible only inside this class. And then when we do a deposit, when we call the deposit function, we just do self.balance plus equal to amount, which means we are adding the new amount to the balance. Next, if we have to get balance of that particular account, we just do self.return self.underscore underscore balance. This protects your data and makes your program more secure. Checks from the class bank account, B1 equals bank account. Now let's try to get balance. It should print 0 because that is the default value. Now let's try to deposit 100 rupees. So B1 dot deposit, and then in bracket we pass in the amount, which is 100. And then we again try to get the balance from the same object. It should print 100. Let's see the output. Next is abstraction. You drive a car, you turn the steering, press pedals, but you don't worry about how combustion works. That's abstraction. It hides complexity and shows only what's necessary. In code, we do this by building clearer interfaces. Next, what's inheritance? Let's say you have a class animal. You want to create dog, cat, and bird. So instead of copying code, you let them inherit. So in this code, we have class animal, which has definition speak, which prints this animal makes a sound. And then we create another class dog, which inherits animal with the same definition speak, and then it prints dog barks. Now dog has all of animal's powers, but can also do more. Next, polymorphism. Poly means many and morph means form. Same method, different behaviors. Be the dog class and create two more classes, cat and bird. After we are done with this, let's try to create animals with different classes, dog, cat and bird. So we say animals equals, in a list we pass in dog class, cat class and bird class. For A in animals, and then we call A dot speak. Now if you notice here, every class has its own speak method. Hence, every class will print differently when a speak method is called for that object. Let's try it out. This is powerful. You can write flexible code that works with many object types. Alright, so let's take everything we've learned so far about OOPS: classes, objects, attributes, methods, and even inheritance, and apply it in a real-world mini project. We'll build a library system where you can add books, list available books, and allow users to borrow or return them. Now, every library has books. So let's create a book class. It will store details about a single book, its title, author, and genre. Let's type it down. Class book, which has definition in it, which takes three parameters: title, author, and genre. And then all we do is self.title equals title, self.author equals author, self.genre equals genre. We add one more variable which will say self.available equals true. This will be our default value. We've got three main attributes: title, author, and genre. And here's the cool part. We add a fourth, available. This keeps track of whether the book is in the library or currently borrowed. Now let's add a string representation. If we print a book object, we don't want Python to show us that weird book object thing, right? Let's make it more readable. So we add one more definition, underscore underscore string, which will say status equals available if self.available, else we'll say it is borrowed. And then all we do is return self.title by self.author and then self.genre in the brackets hyphen the status, whether it is available or borrowed. This lets us print the book directly and see its detail, including whether it's available or not. Now we'll build the actual library. Think of it as the collection that stores all the books and provides methods to add, remove, or display them. So let's create a class library, which again has init method and then self.book equals empty. Simple so far? We're creating an empty list of books. Now let's build some tools into this library. Let's create a definition to add a book. So definition add underscore book, which takes argument book. In this function, all we do is we append to our books array that we just created above. And then we print book added book.title. This allows us to add a book object into our library. Notice how clean it is. We just store the whole object, not the individual fields. Method 2. Remove a book from the library. Definition remove underscore book, which again takes the title for book in self.books, and then we check if book.title equals title. We do self.books.remove and then book, and then we just print book removed successfully. And if we do not find that book in our library, we just print book not found with the title. Here we used a for loop through the book list, checked the title, and removed the match. Always return after removing, otherwise you risk looping unnecessarily. Next, let's display all the books in the library. So for that definition, list underscore books, and then all we do is not self.books, which means if the books array is empty, you just print no books in the library, and then you return blank. Otherwise, if it is not empty, you loop in through that books, and then you keep printing book. Straightforward. If there are no books, tell the user. Otherwise, print each book with the string method we defined earlier. Step 3. Add the user class. Okay. Time for a little magic. Let's create a user class which tells if someone has borrowed or returned the books from the library. So we have class user, which again takes the name variable as a parameter. And then if the person has borrowed any books, it has an array to keep a list of it. Every user has a name and a list of borrowed books, so we can track who's taken what. Next is borrow book method. So we have a definition borrow underscore book, which takes in two arguments, library and title. Now we loop in through all the books in the library for book in library.books. If book.title equal title and book is available, then first thing that you do is you mark that book as unavailable. So which does this book.available equal false. And then you do self.borrowedbooks.append book. So this adds the book title to the user who is borrowing it. And then you return self.name borrowed the book title. And then you return. Again, if you did not find any book in the library, you just say book not available or not found. This just checks if the book is available. If yes, it marks it as unavailable and adds it to the user's list. Next, return book method. Definition return book again takes two arguments, library and title. We again loop in through the self.borrowed books. We check the title of that book. We mark that book as available in the library and then we remove it from the user's borrowed books list. And then we print self.name returned the book title. And then if that book is not found in the library, you just write self.name hasn't borrowed this title. Same logic but in reverse. Make the book available again and remove it from the user's list. Now, let's wire it all up and see this in action. We'll create two objects, book 1 and book 2. Book 1 will be 1984, Dystopian, written by George Orwell. And then the second book would be Harry Potter, which would be written by J.K. Rowling. Now, what we do is we create a library, lib equals library, and then we add both our books in that library. So we call the add book function in the library class, lib.addBook, book 1, and then lib.addBook, book 2. Next, let's print all the books in the library. So again, we use the object of class library, lib dot, and then call the definition list books in library class. Now, let's create a user and borrow a book. User1 equals user followed by my name, Anna. User1 dot borrow book, lib, 1984. Print books again after borrowing, lib dot list books. And then after doing this, let's return this book again. User1 dot return book, lib 1984. Now let's print the available books in the library again. You'll see how every part interacts with the other. And that's OOPS in action. Well, you've just built your first complete object-oriented system in Python. We've used real-world design thinking. We've handled user interaction. We've practiced encapsulation, abstraction, and more. You didn't just code, you created logic. That's what devs do. When I started out, I wrote messy scripts. Everything in one file. No classes, no structure. I remember my first freelance project, a web scraping tool. Midway, the client changed the requirement. I had to scrape everything and start again because my code wasn't modular. Then I learned OOPS. My next project, clean, expandable, and easy to change. That one got me more reference, more gigs. That's when it clicked. OOPS isn't just for code, it's for career. You've just unlocked a whole new level of Python, whether you realized it or not. You now think more like a developer than you did an hour ago. If this video helped you, give it a like, and hey, hit subscribe if you want more deep dive tutorials like this. Comment below with I built my first class if you reached this far.